Hey guys, welcome back to another video. Today I wanted to do something different, and that was to share a recording of a webinar that I ran on unit conversion. So this is quite a lengthy video, it's about 90 minutes, but it's really in depth and I think would show you absolutely everything you need to know about unit conversion, how it's presented in the GAMSAT, and how you actually solve those problems. So I think it was a really valuable webinar, and that's why I wanted to share it with you guys. So grab a drink, grab some popcorn, it's quite a long one, and just settle in and just try to follow through the video, and I hope you enjoy. And don't forget to like the video and subscribe to the channel, and please let me know if you like this kind of longer form content in the comments as well. So welcome everyone, and if you're not here, welcome to the recording when you end up watching that. But today, I wanted to go through unit conversion. It was one of the things that a few people messaged me about that was challenging in the maths ebook. So I thought it'd just be good to kind of go through it. So I thought I'd just spend a little bit of time at the start just telling you a little bit about who I am, because a lot of you haven't met me. And then we'll kind of jump into a bit of a worked tutorial workshop kind of thing. I don't know how long that's going to take. I haven't run one of these before, so it's all a bit of a trial. But yeah, just kind of working through unit conversion. And then we're going to do some practice questions at the end. And I think that's going to be where I want to spend most of the time, because I think that's really where, where it becomes most valuable, when you can actually see it applied as well. So if anyone wants to just unmute themselves and ask any questions at any point, I'd really encourage you to do so. I think you'd probably get more out of it if you participate, but obviously no pressure. I'm very happy just kind of running through everything, but I'll be asking heaps of questions along the way. So even if you can just type in the chat. Okay, we've got an AI note taker as well, which is good. But yeah, just feel free to chuck anything in the chat, unmute yourself, whatever you're comfortable doing. But I think you'll benefit more if you are stuck with something, if you can ask the questions. So go nuts. So anyway, so a little bit about me. So my name's James. I just finished my first year of medicine, which was largely enjoyable. There are a few hard moments, but it's really good. And throughout the year I've been, and also last year as well, I've been tutoring the GAMSAT, particularly section 3. And I really like teaching and tutoring in general, but I found the GAMSAT quite interesting to tutor with that kind of problem-solving element. So it's kind of been my main focus and what I enjoy tutoring the most. And that's why I've kind of generated a few free resources and doing things like this, because I actually find it quite enjoyable and helps some people out, and it doesn't take up too much of my time. So that's about me. I've got a background in science, but I actually think it doesn't particularly help with the GAMSAT. So if you're from a non-science background, don't feel like you're going to be overwhelmed with heaps of stuff. I try to make these as simple as possible. All right, so just a little bit about unit conversion before we jump in. So basically what we're trying to do with unit conversion is just convert units. So it's very common in the GAMSAT for it to be integrated into questions. So sometimes it might be a really simple one where the units on the graph are different to what's in the question, and you've got to convert the units quite quickly. And some questions, and that's what we'll try to focus on today, are what I'd call more pure unit conversion questions, where that is the question itself. So you get kind of a wide range, but I do see it pop up quite regularly. So I think it's a really important skill, which is why I put it in the book, and it is quite a challenging skill, and I think that's why they assess it. Okay, so I'll just start this broadcast on my iPad as well. There's a bit of technology to sort out today, which is... So I think that should be good. Can someone just let me know if the iPad is the biggest screen? Yep, Cedric, far away.
Well, I can see the screen, sorry.
No, that's all right, perfect. So that it's, yeah, cool. That should be good then. So there are a few, I kind of there's a few skills that usually I would go through before jumping into unit conversion, and those are scientific notation. I'm not going to write them out. Scientific notation and index laws are the other ones. I was thinking about if I should go through them today, but it is quite lengthy, and I thought there's the maths ebook, which would be really helpful to go through those two sections. And I've also got a few of you, I've just started a YouTube channel as well, so it's pretty small at the moment, but I kind of go through a few of those things anyway. So if you are struggling with the scientific notation or index laws, I've got some stuff on that as well as some other stuff as well. So if you go to YouTube and just search my name, which is James Merriweedy, you should be able to find that somewhere in your emails or whatever. You should be able to find me, and then it's basically just an intro into that stuff. So if you're a little bit rusty on that, hopefully you'll be able to still keep up with it all. But yeah, today I mainly want to focus on unit conversion, but do stop me anytime if you want to clarify anything. So really what unit conversion would be is if you might have something like 60 kilometers per hour. So this is the nice, easy example that I always put in. I think I've got it in the book somewhere. And everyone knows that there's something to do with 1,000, you know, because there's 1,000 meters in a kilometer, and there's 60 minutes in an hour, and so you know these units, you know all of the things that you need to do. It has something to do with 1,000, something to do with 60, but really it's hard to know, and maybe not so much with something like kilometers per hour, but with other units, especially in the GAMSAT, it's a lot harder to know if you're multiplying by 1,000 or dividing by 1,000. And really that's the whole point of unit conversion, is just, or this process, is just to be really clear in what you're doing and just know if you're multiplying by a number or dividing by a number. That's really the whole point of it. So it's just setting out your maths clearly to prevent mistakes. Now, as I said, we've got kilometers per hour here, and let's say we wanted to go to meters per second. So it's a little bit of lag with the iPad sometimes, but I'll try to, it will load if there's something kind of loading there. So we wanted to go to meters per second. Now, if we look at the units we've got, neither of them are in our final units. So we can already see that we want to cancel each of those units out. Now, if we could just multiply this by something. So let's say we want to cancel out the kilometers because we don't need those ones anymore. If we could magically put some kilometers underneath somehow, you know, just in a fraction like this, these kilometers would actually end up cancelling out because we've got the same thing on the top and the bottom. So anything divided by itself is just 1. So, you know, if we had 5 divided by 5, that equals 1. And it's exactly the same with the units. So kilometers divided by kilometers just equals 1 as well. And that means we can just cancel it out. So if we could do that, then that would be really good for us because we can get rid of some units that we don't need. But obviously something feels wrong about doing this, and we're obviously just changing the value of that equation, which we can't do. But, so we take another little side step for a second. If we multiplied by 1, that is okay. And what I mean by that is if you had, let's say 5, and I'll write the denominator as well to make it clear. If we had 5 over 1 and we multiplied that by 3 over 3, this is, as I said, this is 1 because the top is the same as the bottom. And we know that that's okay because what this would equal is 15 over 3, which is just 5 over 1. It's exactly the same. We've just kind of scaled up that number. So the other rule that we can use for unit conversion is if the top equals the bottom, then that's okay mathematically. So if we go back here, if the top equaled the bottom, then that would be fine. So we could put something like a kilometer in here, and that would be all right to do. But as you can see, it doesn't really help us in any way because we've just crossed off a kilometer, but now we've introduced another one. So we've gone nowhere. However, this is where you can put your other units. So for example, we could put 1,000 meters because 1,000 meters is equivalent to 1 kilometer. So you can already see that now we know that we need to multiply by 1,000 if we want to convert 60 kilometers per hour into, and this would be at the moment, meters per hour, because they're the only units that we have at the moment. And that kind of makes sense because if you think about it, that would be 60,000 meters per hour, which is obviously 60 kilometers per hour. So I hope that makes sense. I'll just pause quickly. Did anyone have any questions with that? Feel free to just chuck it in the chat. Looks good. Okay. So we can keep going with this. And now we have hours that we want to cancel. So remember, we're going into meters per second. So we have hours which we want to cancel, and they're on the bottom of our fraction. So to cancel that, we need to put hours up the top. So this is my whole process really, is step one is identify the unit that we want to cancel. Step two is to write that on the opposite side of the fraction. And step three is to make the other side of that fraction equal to the first side, if that makes sense. So in this case, we've identified hours, put it on the top because that's the opposite side of the fraction. And then we need to make the denominator equal to 1 hour. So that would be 60 minutes. So then we can cancel out the hours, and that's why we end up dividing by 60 minutes. And then we can do that again. And whenever you're doing this, if you have something like 60 minutes, I just want you to focus on the unit. So it's unit conversion. We're only using the unit. So don't write 60 minutes up here. You actually can, but I won't go into why it's fine. I think it's easier for now just to always just only do the unit. So instead of putting 60 minutes, we'll just put a single minute. And then we put 60 seconds down below. And then if you look at the units that we have left, we have meters per second, which is what we wanted. So that's perfect. So once we have done all this, we can then just rewrite all those numbers. So we have 60 times 1,000 over 60 times 60. I always put the numbers over here and I put the units just somewhere separate. And the reason is that my S's look a lot like fives. And I believe in the past, I've actually kind of grouped it all, or I've taken a shortcut and I've tried to do all these numbers and I've actually thought that's a 5. So I've ended up multiplying my denominator by 5. And those are the kind of errors which we really want to avoid, because as you've probably noticed in the GAMSAT, all the answers are quite far apart. But if you make a mistake like that, like including a 5, that's the kind of thing that could get you from one answer to the other. So just be mindful of that. So when we get this, we could just cross off the 60 and the 60, and then I'll just convert this into scientific notation. So I'd actually convert this to 10 times 10 to the 2 instead of 1 times 10 to the 3. These are the same number. And the reason that I do that is because I always like my numerator, so the top number, to be bigger than the denominator. So I could just see that when we get 60 down there, which I'm going to round to 50 as well. So 60 seems like a hard number, so I'm just going to do 50 because that's nice and easy. When I convert this to scientific notation down here, it means that I get a really nice fraction here. So instead of having, if I converted this to 1 times 10 to the 3 divided by 5 by 10 to the 1, it's a little bit challenging, and I think that that's kind of mistake prone. So I think I'd encourage you really early on to look for nice, easy patterns in your maths. So seeing things like you can change a 60 to a 50 and make your maths a lot easier. That's going to make it more accurate and quicker as well. So spotting patterns like that and doing that early, really good habit to get into. And again, making the numerator larger than the denominator, that's another really big thing that I focus on. So when we do these, they'll just be 2 times 10 to the 1. So that'll be 20. And that's an approximation because I have obviously rounded that number. So did anyone have any questions from that? Cool. That's good. All right. Hopefully I've done a pretty good job of that. But yeah, as I say, if anything's unclear, just feel free to pop a question in the chat. So we'll do one more example. I might just leave it to you guys and then you can give me some answers. So if we had 10 liters per, what are we going to do here? We'll do 10 milligrams per liter. And I want these in kilograms per microliter. It's a little bit of a hard one. So I'll give you guys a couple of minutes. Actually, I'll ask what you want. So do you think it would be good to leave you with this one to work out, or would you rather me just work it out kind of like the one above?
I think we can try.
Perfect. I like that. Thanks, Arthur. All right, I'll give you guys a couple of minutes. Let's get myself a water. I'll be back in a second. Just in case anyone's stuck, there's 1,000 microliters in 1 milliliter as well. And that's not a very clear M. My writing's quite bad. So I'll give you maybe one more minute and then I'll see how everyone's going. Okay. Well, has anyone got an answer and are they willing to share or should I go through it?
I got one answer, which was 10 to the negative 7, but it felt wrong, so I'm redoing it again.
Okay, 10 to the negative 7, that's 1. Did anyone else get that answer? Oh, we had someone with 1 times 10 to the 7 divided by 10 to the 3. So that's another one. Anyone else? We've got 10 to the negative 8 as well. So this one would be 10 to the 4, I guess. So we've got a few different answers. Okay, well, let's step through it one by one. So we've got 10 milligrams per litre. Now you can start anywhere with these problems, but I think it's really handy to just work on one unit at a time and just go step by step. So we could start with any, but I guess I'll just start with the milligrams. Sun's just gone right in my eyes, which is very annoying. I'll start with the milligrams. So the process is: first step, identify the unit. Second step, put it on the other side of the fraction. Third step, put the other, and maybe this is something I didn't, now I'm thinking about it. Sometimes you need to actually balance the side where you're putting the first unit. So if we're going into kilograms, so what you can do is step 1, step 2, step 3, write your new unit, and we'll add a step 4, which is then you balance it out. So there's 1,000 milligrams in a kilogram. So now that's balanced there. Hope that makes sense. And once we cancel out the milligrams, we'll see that we've now achieved our first unit. So that's good. So litres to microliters. Now it's a little bit harder. So again, step 1, identify the unit. Step 2, put it on the other side of the fraction. Step 3, put our units that we want. So I'll just go to milliliters. So I always just go one step at a time. And then step 4 can be balance that out. So there's 1,000 milliliters in a litre. So that's balanced. So now that litres is cancelled out. And then we just go with the milliliters. So again, we just do the units. We don't worry about the numbers. So we put 1 milliliter up here. We put a microliter down the bottom. We cancel out our mils, and then we balance that out. So there's 1,000 microliters in a milliliter. So Arthur, new answer is 10 to the 7, 10 to the positive 7. Well, it's looking like your first one might be right, actually. So we'll simplify all this. So we put the 10 on the top. There's no other numbers on the top. It's just units. And we've crossed them all out. So we just put the 10 on the top, then put all these down the bottom. So we've got 10 to the 3 times 10 to the 3 times 10 to the 3. And we've got kilograms per microliter. So just putting all the units over somewhere else so we don't get them confused. And then convert this all to scientific notation. So that's the same as 10 to the 1, really. And then the bottom will be 10 to the, so it'll be 3 plus 3 plus 3. So it'll be 10 to the 1 over 10 to the 9. And then we've got, so that with the other index law, we get minus. So it's 1 minus 9. So the final answer will be 10 to the negative 8. So Thumith, I hope I said that right, but yeah, you got the right answer, so well done. And Arthur, you're very close the first time, and then maybe you doubted yourself because it was a bit of a weird number because I've given you some weird units to do. But yeah, you're very close the first time, and then something's happened the second time.
Isn't it, though, with the kilograms to milligrams, it's 1,000 milligrams in a gram and then 1,000 grams in a kilogram. It's not 1,000 milligrams in a kilogram, I think.
That's embarrassing. That's really embarrassing. You're 100% right. Yes. Who's teaching who? So there's 1,000 grams there. So I'll color code this. You're 100% right. I'm so sorry about that. So now we'll cancel the grams out and 1,000 milligrams down here. Cancel, cancel. Actually, what have I done now? Yeah, I think I've done this all weird. I've done this all backwards now. Hang on. I'll fix this. I promise. So, sorry, everyone. That's embarrassing and very confusing for you all. So that would be the first conversion where we cancel the milligrams. I was just testing you guys. And then to get this last one to kilograms, then we'd put grams on the other side of the equation, then kilograms, and then 1,000 grams here. So cancel, cancel. So that actually means we have another 10 to the 3 down here, which means this would be 10 to the 1 over 10 to the 12. So this would actually be 10 to the negative 11. Oh, I read microliters mil. Yeah, look, that's probably my writing as well. Sorry. But yeah, if you got the right answer with mils, then that's perfect. That's that's my fault, because if you were reading it, you would have been reading, printed text. So if it's just because you've misread my text, that's perfect. That's really good. So I'm really sorry about that mix-up. I'll blame it on being distracted, but yeah, I think it was just a bit of an error. So yeah, so does that kind of make it all a little bit clearer for everyone? Hope it does. I'll just go on to one other little thing that I think you need to know with unit conversion, and that's so this is all well and good, but sometimes I find it gets a little bit confusing in the GAMSAT, because they might introduce something like how many. I mean, I've got a few of these examples in the ebook as well, but how many what am I going to do? So how many? Well, actually, what I might do is maybe we'll go to a practice question, and then it should hopefully come out a little bit through there. So we'll come to the kind of problem, I suppose, if you will. So we'll go to if everyone's happy, I'll go to the practice questions now. These are just the ACER practice materials. So if you've got that, you might have seen these, hopefully not, but hopefully you'll still get something out of that. But I wanted to kind of give a few things as well, because when we do this, it's nice and controlled and easy, and I like to think of this as a skill. So you need to have this skill, but it's kind of another challenge to be able to identify when to do that in the GAMSAT and how you can actually use this skill. So it's not always exactly clear how to use the skill. So when we go to the question, so that's why I'm kind of explaining it without the question there, I want you to think about how you can use unit conversion specifically, and then hopefully in the future, once you get more and more developed, you'll start to see ways that you can use it all the time. And with the questions as well, I've also scribbled out the answers, because I find what a lot of people do in the GAMSAT, and I don't blame them, is that they read the question and then immediately they start looking at the answers, or they go back to the STEM, and I think what's happening there is because they don't immediately know how to solve the question, they're looking for additional information. I think that's what our brain does. We look for easy ways out. So we look for something that's easier than what we're faced with, and we hope to find the answer. But in my opinion, I don't think you often reach the conclusion that way. And I think the best way is to really force yourself to solve the problem. So I've scribbled out the answers, and what I kind of want you to do is just look at the question and think about what's the situation when I would be able to solve this, or what additional information do I need to do? So just really force yourself to think, how could I solve this? Because I personally believe that you can know how to solve a problem just by reading the question. So no information from the STEM, no information from the answers, and you'll be able to actually know how to solve it. So there might be some information that you need later on to bring into that, but how you're actually going to solve it, you do know. So I've had my little monologue, so we'll go to the question now. So it's this one. So I've seen a few people get quite upset with this one because I think it's a stupid question, but I really like it. So I'll just let you sit there for a little bit and just have a think about how you possibly could solve this problem, or I guess under what circumstances would you actually be able to solve this? Could you imagine something that if there was some information, you'd be able to solve it? Those kinds of questions, just keep asking yourself that. And also you've got a clue that there's some unit conversion involved. So I'll maybe just give you maybe a minute or so. I also think this question is quite interesting because actually without the answers, if this was actually a long answer question or something like that, I think it'd be easy to come up with the answer. So, because there's no additional information, so this is all you get. All right, so does anyone have any ideas? Not an easy question. No one's got anything? How long your hair grows? Yep, I like that. So could you elaborate on that a little bit? So I like so we'll just focus on the nails. So why are you saying how often you cut your nails?
Well, the idea is, I guess, if you cut your nails once a week or once a month or once a year, it helps you have more of a perspective of how long it will grow under that time period. So if you
Okay.
cut your nails once a week and you know how long your nail will be until you cut it again, it'll give you a rough estimation of how long it's actually grown under that week period. So we know that it grows quite a lot over a year because you cut your nails more often than once a year. So it can't be
Perfect.
like 1 centimeter a year. So it'll be shorter than that, but longer than like 1 centimeter, or like maybe 1 centimeter every week is probably a bit much because I think you would notice that.
No, I think
You
that's
might
really
also
good.
notice how long your hair grows because people tend to be quite. It gives you a longer amount because you tend to cut your hair less frequently than you cut your nails, but they should grow at roughly the same rate because it's the same protein. So I
I see
thought
what
it
you're
would
saying.
give you say if you're more you if you're maybe this is more important if you're a man. If you've cut your hair every 3 months and it cuts off, you go from a this to a this. It might give you more of an idea of how long it is.
I like
Roughly.
it. I like it. I think, yeah. Look, that sounds really. I'm going to focus just on the nails because I think you've hit the nail on the head. All right, it's a little silly joke there, but yeah, I think that's perfect. So I think you're probably onto something with the hair. I actually didn't know that they grow at the same rate or similar rate, but let's just go with nails because I think you've got it. So 1 week. How long do you think they would grow in a week, roughly? If you had to put a number to it, you said maybe like less than a centimeter or something like that, I think.
I think it would be less than a centimeter.
Perfect. So
I'm trying to. It's difficult to say when it's so tiny and it's a bit.
no,
it's
that's all
hard
right.
to
That's all
decide.
right.
I'd say less than a centimeter.
Yep, perfect. So we'll say less than 1 centimeter. Now, why I really like that. So you've got this. Now, that's essentially a unit of measurement. So we can write that. Now, you said less than a centimeter, so I'm going to say 0.5. What am I going to say? Centimeters a week? Maybe. That might be slightly over, but it doesn't matter. And I'll show you why it doesn't matter. Because they know, I mean, think about what they're trying to assess in the GAMSAT. They're not trying to assess how accurately you can actually estimate that. That's ridiculous. And if you actually look at all these options, we've got these ridiculous units of meters per second. How is anyone going to be able to estimate the units of meters per second? And every time I give my students this question, they freak out because of the meters per second. And I think if you just think about unit conversion as we go from one unit to another unit. And why I said it doesn't matter about this estimate is because if you look at these answers, they're all a factor of 1,000 apart from each other. Do you see that? So let's say that the correct answer was 0.5 centimeter, and that corresponded to option A. That would mean that option B is 0.005, C is 0.000005, and you get the idea. So if you're anywhere in the ballpark, you're actually going to still get the right answer as long as you do your maths well. So really this is about, can you set your maths out correctly, which is what unit conversion is for, and can you apply your index laws and do your maths appropriately? Okay, so that's the whole point. So we've actually think about unit conversion as, is there a reason why I can't put some information into mathematical form in the form of a unit, right? And that's exactly what you did. You said, I know how much it grows over a certain time frame, so therefore you have a unit of measurement over time. That's perfect. And once we have any unit, we can then convert that to any other unit. So I'll give everyone a little bit of time as well. Maybe I'll just maybe 2 minutes. We'll see how we go in 2 minutes because I do want to get to some other questions. We'll see how everyone goes. I think it's good to practice this as much as possible. And after my little mistake, maybe I need a bit more practice as well. Okay, so that's 2 minutes. So if you're not quite there yet, that's all right. I'll just start. Does anyone have an answer? But before I start, just A, B, C,
My
or D?
answer was like a couple of numbers, and then altogether it was -8. But I think the numbers altogether will be higher, so I have the answer C.
Perfect. Okay, cool. So we've got 1 for C. Anyone else for C? Okay, I'll just get started. So we'll just start with the centimeters. So centimeters on the bottom, go into meters, 100 centimeters in a meter. So they cancel out. 1 week, 7 days. So get comfortable with these weird units, because like weeks and days and stuff, because that's what they're ultimately evaluating you on, is can you do that? Can you do this skill with kind of weird units? That's the whole point. I also put C, but I could, so we've got 2 for C. So again, we've got this. I'll tidy everything up. So I'll just put 5 by 10 to the minus 1 on the top, divided by 10 to the 2. I'll write them all out first. So I'm really loose with my estimation, and I think as long as you don't go too far, I think it's perfectly reasonable. And I kind of have a rule that if it's easy, just keep it. But if it's hard, like keep the accuracy. But if it's hard, get rid of it. So that's 7. I'm just going to change to a 10. The 24 into 20. And then I'm actually going to leave these as 60 for now, because I can kind of see that I'm going to be able to multiply 6 by 6. So it's all about just spotting patterns in the maths. So I'll just highlight these so you can see what kind of inaccurate maths I'm doing. Okay, so the 5 by 10 to the 1 can just stay like that. So if I've got things like this, I like moving all the numbers to one side. So we go 6 by 6 by 2, by 10 to the 2, by 10 to the 1, by 10 to the 1, by 10 to the 1, by 10 to the 1. Sorry, I got a little bit messy there. So as I said, 6 by 6 is 36, times 2 is 72. And then we just do all the 10. So 2 plus 1, 3, 4, 5, 6. 10 to the 6. 5 by 10 to the 1. Have I done something wrong here? I feel like I have. No, I'll go with it. That's -1. That's what I was doing. It's like, that's not 50. That's not right. So again, I make the numerator. I always have this rule. I make the numerator bigger than the denominator. In this case, I'm actually just going to make that 50 by 10 to the minus 2 over 50 by 10 to the 6. So you can see I'm really loose with the maths, because these are really far apart. And I think changing something from 72 to 50 probably isn't going to change my answer at the end of the day. So, I think that's fine, and it makes my maths easy. So that just becomes 1 by 10 to the minus 8. And yeah, the closest answer would be C. So the effect really of, all these estimations that I've done here, like changing some of these numbers and then, changing these numbers and maybe even our original estimate, they're probably the reasons why we're a factor of 10 away, which is actually quite a large amount. But it'd be very hard to get another 10 away, if that makes sense. So as long as your estimate at the start is relatively reasonable, which I think 0.5 centimeter is, you're never going to get the wrong answer, if that makes sense. So yeah, anyone have any questions about that one? I think everyone did really well, at least from the answers I can see. Arthur, that was very good to get the start. So I think just think about that as unit conversion is just a tool where you can go from one unit to another, and really the hardest part is just rearranging the problem to suit the skill that you want to use. So I had another one here. So we're just doing 33. So according to figure 1, so obviously we're going to need to go back and get some information from a graph, but I want to just go through that exercise again. Can we, I'll just quickly answer that question. If we got this in an exam, would you say to start by thinking nails would maybe grow 0.5 centimetre a week, or would you go straight away to thinking about it in terms of the units given as solutions? Well, with this one, I mean, if you think about it this way, in the exam, it's not going to say 0.5 centimetres per week. Whatever this is, that would be 500 centimetres per week or 500,000 centimetres per week. If you think about it, they're not going to give you units that you can just instantly look at and know the answer. You're going to need, there's always going to be a problem to get there. So I think if you're ever needing to use unit conversion, which you will, it's because they will give you dodgy units that you need to get into something that you can appreciate, because no one will know instantly just by looking at it how fast your fingernails grow in meters per second, because there's no way you can appreciate such a large dimension in such a short time frame when they grow so slowly. So I think I get what you're saying, but yeah, I think just unit conversion is just for those ones. It doesn't really matter what the unit is, because as we just did, we went from centimeters per week into meters per second. If you've got one starting unit, you can go into anything. So I'd like to think about it that way, is that I've got this skill that if I can get a unit, I can get it in any other unit. So it doesn't matter what the units are. So to answer your question, I know it was a long answer, I would think, what's my starting unit? Because that's the only thing I'm missing. If I've got the starting unit, I can convert it into my finishing unit. Okay, 33. So what's the total amount of energy produced by the Mallee fowl during its 60-day incubation? So again, I want you to think, just have a little think about this, about what is the scenario when you would actually be able to determine how much energy has been produced. So I want you to just have a little bit of a think about that before I show you the graph. So blurt out any answers or type out any answers that you think. And there's multiple ways that you could, but I think it's just really helpful to think about, how could this problem be solved? What are some circumstances when I could solve it?
Maybe like how much food it's eating.
Perfect. So, yep. So how much? So could you explain that a little bit more? Like, are you thinking if we had like a table or something that said it eats this much food on this day, this much on the next day? Were you thinking something like that?
Yeah, basically, because I mean, especially if it's incubating an egg, it probably isn't like the amount of food it's intaking should roughly equal the amount of energy it's expending. You know, the sort of calories in, calories out thing, because it's not actively going to be like increasing or decreasing in weight when it's incubating. So I thought that would be a relatively.
So if you had that information, about how much it's eating, what would you do with it to get the total? Just add it all up?
Could do. Or you could average it. Like if you have a couple of days, average it and then times it by 60.
Perfect. Exactly. So that's what I like it. So you could either add up all of these to get a total. So that would just be plussing these all together. Or if you had an average, if we could find an average value, we could then multiply that by some kind of time frame, right? So that's really good. So you're thinking really, really well, Arthur, about ways that you can solve the question. So when we go back and we because you don't even know what information's there. But when you do go there, you'll be able to hopefully see if one of these or which one of these is the way to go in terms of solving the problem. So I'll rub out all this now. So we need our answer in kilojoules. When we go back to the question, there's heaps of information here. My recommendation is always read the question. That's why I'm giving you the questions first, because I actually think you need to know how to solve it before you go back for the information. And then with that, you're looking for whatever you think is the way to solve it. So if we're looking for either, daily averages of food or energy or something like that, or an average, we're just going to skim through this. It doesn't look helpful, and I'll just save you the time. It's not helpful. But this graph all of a sudden is helpful. Okay, so hopefully your eyes are drawn towards metabolic rate. And then we've also got this incubation period. So how could we, what's kind of the way forward from here? We don't need oxygen consumption. Yeah, so there will be a recording. So I'll send out some details on how to get the recording. But thank you very much for coming. And yeah, you can watch the rest in the recording. So yeah, anyone got any ideas about what we could do here?
If we find the graph and we take like the halfway point, that should approximately be the average over the time period. And then you
Perfect.
take that average, you times it by 6, and then that average you can use to find 60 days.
I like it. So you're saying like this point, that one? Something like that?
Yes, roughly.
Yeah. I think that's really good. And it's obviously going to depend on the graph, because if there was a graph like this, then you're going to have to interpret it a little bit more to think of what the average is going to be. But because this is quite a straight, that's a straight-ish line, we should be able to just take the middle point and that will give us a good average. And again, if we look at the answers, they're all really far apart. So we should be able to estimate that. We don't need to get it exact, but if we have anything reasonable in the ballpark, we will be able to get the answer. So let's just go with this one. So we've got 0.15 joules per second. And now you can see why this is a unit conversion question, because we need units in kilojoules. And I'm going to leave the denominator for a second, but let's just kind of work through it. We know we're going to need something in the realm of days. So we'll do times 1000 joules per kilojoule. That cancels out my joules. Times by 60 seconds per minute, times by 60 minutes per hour, times by 24 hours per day. All right, great. So once we do all this, the units that we're going to have are going to be kilojoules per day. Now we need 60 days, and you kind of alluded to it earlier, Arthur, that we can multiply by 60. But I want to show you a bit of a mathematical way that you can do this, and I think it's more helpful to do it mathematically, because there are instances where it's not so clear if you need to multiply or divide. So what I'm talking about is basically making up a unit. So I call this a dimensionless unit. So I'm going to say that just like 1 kilogram equals 1000 grams, that's what I learnt earlier, one time frame, so this is the unit that I've just made this up. This is completely imaginary, but one time frame equals 60 days. Okay, so if the two units equal the same thing, we can just put them into a fraction and just do what we've been doing with our unit conversion before. So, for example, that means we can just times this by 60 days per time frame. So time frame are our final units. So if you look at our final units now, we've got kilojoules per time frame. the days are cancelled out, and it means we end up multiplying by 60. So that's what you said intuitively. You said, well, if we have the average per day, we just multiply it by 60 to get it per 60 days. But this is a good example of how you... Oops, sorry, that was my dog. That's a good example of how you do it mathematically. And the next question that we're going to do will be should hopefully demonstrate this quite well. So I probably won't, just for the interest of time, I probably won't go through the answer. But basically you just multiply all these numbers together, you'd get some number, and then that will be your answer. Okay, does anyone have any questions? This part does sometimes confuse people, this kind of dimensionless unit. So if you have any questions, feel free. Because again, the whole point of unit conversion is just to set out our maths clearly, isn't it? So if we haven't done anything dodgy, because remember, one time frame equals 60 days. So our final units are going to be in kilojoules per 60 days because a time frame equals 60 days. So there's nothing dodgy mathematical going on. It's just a really nice, easy way to set out your maths clearly. So I'll leave that there. I hope that makes sense. But if not, we're going to have more of that dimensionless unit in our next example as well. So we'll go back here. We're not going to do that fingernail question anymore. It's 28 or something, I think. Cool. So it's this question here. So 29. And again, your brain should be clued on as soon as you see some units and you see all these other units of measurement, you should be thinking about ways that we can manipulate our starting units to get the final ones. So I'll leave everyone just with that one for maybe another 2 minutes or so and just see how you go. So you might be noticing that oh, it's not working. Hang on. You might be noticing that a lot of these really what's my maybe this is not good. My Apple Pencil might have died. That's a disaster. But you might be, what I was going to say is you might be noticing that a lot of these units kind of are dimensionless units. So we've got something like single annihilation is approximately 10 to the negative 13 joules. Ten to the 9 annihilations per second. Has anyone got anything looking like an answer? It's a bit of a tricky one. No, that's all right. So I think this one's a really good one to Cedric stumped as well. Okay, well, I'll just quickly check what's going on with my pencil. Hang on. It says it's charged up. I don't know what's going on. Okay, it's back. Phew, crisis averted. I would have had no idea what to do if that died. So let's just think about, let's work through it. So we know our answer is in grays. So we need, and grays are equal to joules per kilogram. It's probably a good time to mention as well, all the ways that you can see units represented. So you could see something like, you could see it as joules per kilogram like that. You could see it as joules per kilogram -1, or you could have it as joules per kilogram. These are probably all three of the ways which mean the same thing. So if you see any of these, it means that that unit is in the denominator, okay? So joules per second, that's one. There's your -1. Even something like needed for a PET scan, that can kind of give you a hint about where it is. Anyway, going back to our units, we need grays, which are equal to joules per kilogram. So where would I start? Well, we need joules in the numerator. So let's start with that. So kind of like how I was telling you guys before, is thinking about how I'm going to solve the problem. Now, at this point, I don't immediately know how I'm going to solve it, but I know that I need to get joules into the numerator. So I'm just going to start with, there are 10 to the -13 joules per annihilation. Okay, so I've interpreted that sentence as this unit. So again, it's similar to that, what was it, fingernails or toenails or something disgusting. Similar to that first question, where we're really just trying to interpret sentences into some kind of mathematical equation, because once we get it in a unit, we can then use our unit conversion. Now, as we've been doing, I can identify that we don't need annihilation. We need kilograms. So I don't know how I'm going to get that in there yet, but I know that we don't need annihilation. So why don't I go and try to cancel it out? So maybe I'll look at this next sentence. It says there's 10 annihilations per second. 10 to the 9 annihilations per second. Okay, so again, these are essentially dimensionless units. One of them is equal to the other, so we can just put them into a fraction. And what that means is these annihilations cancel out. Now I'm thinking, okay, well, that's good. But now I have seconds. So how can I cancel seconds? Well, I can see that we've got 20 minutes in there. So, so I can do times 60 seconds per minute. That cancels out my seconds. This is probably taking up a little bit too much space. It's quite a lengthy one. So you can see I'm just gradually working closer and closer to the goal. So then I can times this by 20 minutes per PET scan. Okay, so again, another dimensionless unit there, which I got from that purple thing. And now we just need kilograms. And this one's a little bit, I don't know, it's a little bit loose, but I guess all we know is that we need 60 kilograms. So this one, I guess you just got to take a little bit of a leap of faith. I struggle to explain this one completely, but we know that we need to introduce kilograms into the denominator. So I'm just going to put it here, 60 kilograms per person. So it's a little bit loose because I'm not cancelling out the PET unit, but it kind of makes sense because if you look at all the units that I have left, I have PET, person, kilogram, joules, kilograms. Okay, so it's kind of like the number of grays per person per PET or something like that is how I reason it. So I guess even if you don't know 100%, you know that those units need to go in there in the denominator, and you know that you can still multiply by, because all we're doing there is multiplying by 1. So we're actually not changing the value of that. We're just adding another unit, which is fine mathematically. Okay. So when we do all this, so I'll get all the numbers down. So 10 to the negative 13 times 10 to the 9 times 60 times 20 divided by 60. And then we've got all our units. So person, joules, pet, kilogram, which is just, that's our grays unit, joules per kilogram. And when we do this, we can see that the 60s cancel out. So we end up with 20 times 10 to the minus 4. Okay, so if I add those together. Now, this is why it's also really important to track your units as you go. So you overcomplicated that, but you had the right general idea. That's perfect. The more you practice this, the better you'll get at it. So it's 20 times 10 to the negative 4. So getting out of scientific notation, 1, 2, 3, 4. So it'll be 0.002, which is answer D. Okay, so I hope that made a little bit of sense, but I think it shows how versatile unit conversion is, and that there are a lot of questions that are purely unit conversion. Like this one, pretty much all the ones that we've done today are all about unit conversion. And there's that, I'll leave that there actually, it's probably good to look at. So there's some that are just purely unit conversion, which are the ones I picked out today, but more commonly it's going to be integrated into a question. So I always say to people, if you see any unit, you really need to be checking that unit to see if you need to do unit conversion. So for example, if I just scroll through to, I bet you it's going to be ages until I see something with a unit. So even if I just see something like this, if I see centimeters, I'm just always checking that in here, there is centimeters somewhere. Seems like this one's fine. But that's just something, that's a habit that I'm into, because unit conversion is that common. You really need to, oh, thanks for coming, Arthur. So yeah, it's really common. So I think it's not always going to be just a clear-cut question where it's only unit conversion like this, but a lot of the time you will need to just do little unit conversions here and there as part of a question. And occasionally you might see something like this where that's the only skill you have to do. So that's really all I had for today. I think we've gone through a lot. Like we've gone through the basic unit conversion, the skill itself, and then also a few practice questions, and also the dimensionless unit, because I think that's a really important thing in the context of the GAMSAT. So I hope that that's given a little bit more context to things, maybe helped a few of you out. Did anyone have any questions or anything that you wanted me to go through quickly? Because I didn't really have anything else. My pleasure. Gota, hope I'm saying that correctly.
Can I just ask one question?
Certainly can, Jennifer.
I found that you said that, like, you know, like just by asking what you need, like what's important for the question, and try to answer it yourself was really helpful. Do you have any other tips similar to that?
I do actually. So I think for maths, it's probably less useful, because with maths questions like this, where it's unit conversion or something, it's usually quite clear what you need to solve. But sorry, I'll come back to your question, Caitlin. I got a little bit distracted. Something that I have been finding quite helpful recently is when you look at a question, if you can summarize that question into 3 words. So it's quite hard, and so I'll try to find a good example. So maybe something like this. So It's actually quite difficult, but I think if you can summarize the question into 3 words, it really targets what you look for in the question. So when I was saying before, like with that nail question, that I want you to just look at the question without the answers, without any other additional info, that's to force you to think about how you're going to solve it. And I think this is kind of doing the same thing. So, for example, if we go here, I might look at mass, water, saturated, or something like that. So it's not perfect, and you're not going to get all of the information, and you're going to have to come back. But you can already see just by thinking about those words that I have highlighted, you'll then go to the question and you're going to be looking for things about mass of water and saturation, basically. So you start to look for this word and then you start to read this because that's about saturation. I mean, I haven't looked at this question and that's immediately where my eyes go. Water vapor to condense, things like that. And then I'll look at the graph and I see water in air. So that seems relevant. So by no means do I have this question solved. I don't know what to do, but, I'm starting to see that as well. 100%, 25%. Maybe that means saturation, right? So if you just really target what you're looking for, I think it means you don't have to read through all that text, and it just really refines how you approach questions.
Right. Yeah. That's really helpful. Thank you so much.
So try it out. And I mean, ultimately, you can try that thing. Like, you can go to any question and just look at the question. Scribble out the answers like I did before and just really force yourself to problem solve. You could also try doing that 3-word thing. I found that's been quite helpful with a few of my students. And just try out different things because ultimately you've got to be able to do the questions fast as well. So the more efficiently you can do them, the better as well. But that was a really good question.
Right. Thank you so much.
No, that's okay. My pleasure. So Caitlin, not relating to this, since you seem to have been successful, any ideas where to get extra section 1 practice questions? Not particularly, unfortunately. I really think that in my prep, I did a lot of work on reflecting on my mistakes. So maybe that's something I'll share. All of you would have access to that Google Drive. So in that Google Drive, there's a document about my reflection spreadsheet. Have a look through that. But you'll see that I spent a lot of effort thinking about what was needed to solve the problems. And I think, but the amount of time that I spent studying, I put more effort into section 3. But I think that the same approach would work for section 1. So I'm not a master at section 1. I didn't put nearly as much time into it. But I think if you can look at that and then try to apply the same logic of what are the steps needed to solve this problem, I think that you might not need extra materials. If people ever ask me for extra section 3 materials, I say do the ACER ones again, because that's something I did, because I would do the question, get it wrong, identify what I did wrong, and then leave it for a couple of weeks and then come back and see if I still make the same mistake after I've put in, some kind of process to help me stop doing that. So for example, with the maths, this whole unit conversion thing I came up with because I kept making mistakes in these calculation questions. That thing where I make the numerator bigger than the denominator, that's something where I did that because I found that sometimes if I was doing this, for some reason, I would say that 1 divided by 5 is equal to 5. I think your brain defaults to that easy thing, which is the other way round. So I think redoing questions is perfectly reasonable. So I don't have any extra ones, but I hope that helps a little bit with the section 1.
I have a question regarding like your spreadsheet, the questions that you recorded you got wrong.
Mm-hmm.
I had a look at those spreadsheets and you scored really high on those practice tests. Did you was this your like first time attempt of those papers and you score like really high, or did you like
So those ones were my first attempts, but I mean, I think the third practice test, I'm just having a look at it now. I scored really well on that third one.
Mhm.
But the second one, I don't think I did very well. I only got about 50% or something, I think, on the second one. So I think that there's a lot of, and the third one is the last one I did. So, I think you can see the progression and you can see all the things that, if you look, I do think there's a bit of a journey there about all the mistakes I was making and then how I went. And I did do these after doing a lot of preparation on the practice questions and the sample questions. So there are 2 other documents which I spent a lot of time on.
right.
So it's not like I just came in and did that. Like I'd already been practicing this reflection thing on those other documents. So I wasn't completely new to it, if that makes sense.
Right.
Yeah, but I think that shows what improvement you can do if you really focus on your mistakes. Because I actually think without that document and without changing different things that I was doing, I don't think I would have
Right.
I would have shown that improvement.
One thing with recording, like reflecting on the mistakes that I make when I was doing the questions, was that like for example, I knew the theory behind it really well, like for example, acid and bases, but I still keep getting different variations of the same like type of questions wrong. And
that's because I ultimately think that there isn't. I don't like thinking of them as like acid base. So
yeah.
if we look at something in here, like if I can, it's going to be a little bit tricky, but I'll try find. Maybe if I search for like pH or something. Okay, so if we look at something like this is kind of about acid base, but it's actually about, all this question is about pKa. So I actually remember this question, but it's given you a pH, and from that pH you need to know how that relates to pKa. So I think there's often very little content in these questions.
Yeah.
It's usually 1 or 2 little concepts. So I think if you're getting the questions wrong, it's rarely with anybody that they don't know that concept. They don't know how to apply that concept
Yeah.
in the question. So, another way is, if you, just to prove it's not a content gap, you can do these questions open book. That's something I've been recommending recently as well. So have a look at the question and think, if I had Google, what would I be Googling right now? What would I be Googling to try to get this question right? And it's very hard to actually come up with something that you would Google. It's really, the information's there. The information's there, but what are you missing? And I think when you start focusing on what you're missing, then you start seeing trends appear, and that's the stuff that you can put a lot of effort into.
Okay, yeah.
I don't know if that makes sense, but
that kind of makes sense, because I do think it's a bit of a rabbit hole once you start reflecting on the questions you got wrong, and you go really in depth to the theories.
Well, I think if your reflection is saying, I need to study more theory, you've missed what the problem solving, the kind of problem is about.
Yeah.
Because
definitely.
this is really one. So just, just quickly, I know this isn't a chemistry thing, but
Yeah.
when the pH equals the pKa,
Mhm.
you get 50% of the two forms. So if the pH equaled 5.21, we would have 50% of this and 50% of this.
Yeah.
Okay. Now the
Mhm.
question said that the pH is lower than that. So it means that we're going to have more of that one. And that's the question.
I see.
Okay.
Yeah.
So
Yeah.
that's literally the question. And it's not really, and then there's another step because you need to relate this to these molecules. But
Yeah.
really all that question is a very basic concept.
Mm.
But that doesn't mean it's easy. It's a basic concept and it's a really complicated application of a simple
100%.
concept.
Yeah. Yeah. I definitely do
So,
find it really hard to apply the.
and look, you're not on. It's not like you're like that's everyone, right? That's why it's a hard exam. So,
Mm.
if the things that you're noting down are things like, I need to study pKa more, that's
Mhm.
probably the wrong thing to study because you probably know that when the pH equals the pKa, you get 50% of each. And if
Yeah.
you don't, that's something that you need to know next time. But that's the key thing, not studying more than that. If you know that information, you actually know all the information for the problem. So things that you could ask yourself is, why did I not relate pH to pKa? Why
Mm.
did I not think of how, the information that I was given, the only information they've given me is pH of 5. So obviously that needs to relate somehow to these things,
Mm.
things like
Yeah.
that, like asking yourself, why did I not think that way? And then trying to, and this, it's not easy. I'm not saying it's easy, but
Mhm.
the more effort you put into that and thinking about why you didn't do something and how you could do that next time, I think is really valuable.
Yeah. Yeah. Thank you so much. Yeah. Those really help.
That's all right. Yeah, I think just keep going ultimately. All right, so we're pretty close to the end time. Did anyone have just any quick little questions or anything that they wanted me to just quickly go through, or had enough of the maths and hearing me talk and the screen recording? Sounds like that's probably everyone's had enough. But yeah, I hope that gives you a little bit to go off. As I said, the recording will be in the event. So if you can find the event in your calendar, I don't know when it will be, probably in a couple of hours or something. It takes a little while to get processed, but it'll appear there at some point. And yeah, if there's anything else, I do plan on doing some more webinars, probably in the new year, and maybe every 2 or 3 weeks or something. So until March. So if there's anything that you want me to cover, please feel free to email me. The email's always open, and you can, just put something in there and we can just go through more topics, but very similar to how today was structured, with like a little bit of content at the start and then just application of that with questions. So I think that's where all the money is. But yeah, I hope that was helpful for everyone. And yeah, any other feedback or anything, just shoot me an email. If you can't find the recording, send me an email. Basically, send me an email if you need anything. But yeah, I'll be in touch with some other webinars. And yeah, I hope you all have a nice Christmas and New Year. And yeah, probably see you in the new year, hopefully. But thanks for taking a bit of time out of your Wednesday. And yeah, I'll see you next time.